Um, Ms. Rita, no, we have not started yet. Can you hear me now, though?
All right. Assalamu alaikum. Hello, everyone. We will start actually after 2 minutes, just to let everyone know that we're ready to start and to give everyone the space to just join us. So 2 minutes and we will start.
I enjoy your background.
Yeah, this is our space rocket, Classera space rocket. Yeah,
That's great.
we're going to the stars.
Yeah. Who knows? Some of our students may get us there.
Yeah. All right. Hello, everyone, and welcome to today's session, Igniting STEM Learning through SFI from Curiosity to Creation. This is Mahmoud Sarok from Classera, and I'm the Partner Success Training Manager. I'm delighted to have you all with us today, actually, in this session and in partnership with Intel. This session is part of our continuous effort to empower our partners, educators, and school leaders with the latest technologies, especially STEM education technologies. Today's session, we will explore how SFI starter packs bring STEM to life by sparking curiosity, guiding learners toward innovation, and applying the 5 STEM learning design principles. Uh, and now it's my pleasure to introduce our expert speaker, Dr. Jeremy, Intel Global Community Manager. Please join me in welcoming Dr. Jeremy, who will lead us through our today's insightful session. Dr. Jeremy, the floor is yours.
Thank you so much, and welcome everyone. I'm excited to be able to be here again for another session. We had an opportunity to do a session a while back, and really enjoyed this community that is being developed here at Classera and their partners. So thank you for inviting me back. Yes, today we are going to focus on STEM and sort of looking at how our Skills for Innovation starter packs can really support that work. I thought one interesting fact about me, I always like to share one, is that I actually was a STEM enrichment teacher for a while and just finished designing a STEM in the early childhood online course for an organization. Because the realization that so often when we think of STEM, we think of it as a high school pursuit, but really to help our students become thinkers who really pursue the STEM approach, we really need to help them begin that exploring their curiosities and developing and creating very early on, so it becomes a habit of mind, becomes a process that they go through. So I'm curious, what do you first, when you first hear the word STEM, what comes to mind? And I do have a place for you to share that. Our host will share out a web link, but you can also see it here at the top, menti.com, and you use that code or the web link that I just copied and pasted over. and our wonderful Classera host will be able to share out with all of you to be able to see it as well. You can click on that link, or if you have the QR code, and it's going to ask you to just put in one word. So what makes STEM uniquely STEM? In other words, when do we know it's a STEM experience is sort of the question. So go ahead and, yep, thank you. See people starting to put some of those in. Please continue to put them in. We're going to show you a few things and then come back and look at the thoughts and such that have been put in there together. So I'm excited to see all of the great thinking with this group. A lot of times, what we hear is science, technology, engineering, and math, because that is what makes up the acronym of STEM. But as many of you are already sharing, STEM learning is really more than just the acronym. It's more than just those different pieces sort of combined and shoved together. And so what I thought we could do is take just a minute. This is from one of our gold ambassadors at the Intel Skills for Innovation program and his classroom. Just take a minute and notice what is going on in this classroom as it is a STEM experience that they're working on. And as you notice things, go ahead and put those in that link as well. This is actually from one of our starter packs, the Catapult starter pack. And as you can see, they're having quite a bit of fun there as they're launching their, he made it in, he's very excited. And they continue to experiment with distances, different strengths of the rubber bands. Then, after they've gathered that information and data on how it works, they get to go into a simulation, as you see here, and actually build a catapult to do the same sort of process that they were doing on the table that they had built with rubber bands, popsicle sticks, and caps. And so what you can see here is that what they learned as they were curious and exploring, gathering that data, they now are applying in a virtual space to be able to, oh my, they just knocked that down, to be able to really move that forward. And so as we think about that, again, what are some of the pieces that make this a STEM experience versus just a lesson? And so let's check in again with everyone and see some of the words that you've come up with here and that you've seen. Oh my, there you go. And so if you're not familiar with word clouds, those words that are most frequently typed in, those become the largest. But what you can see here is we've got hands-on, engagement, knowledge all together. So learning together, that's great. Applying it in life, engaging technology. So you see that this is different than just going into a classroom. STEM learning does look different. It feels different. And so there we go. And so as we have begun to explore and look at that, one piece that I sort of developed is this idea of a STEM learning design framework. And it has 5 pieces to it. And the idea is that within that framework, what we're able to do is really think about how do we make our learning experience truly STEM. And so what we're going to do today is going to kind of explore this just briefly, but then look at how within the starter packs, we're able to bring some of these ideas to life, see some of it in the classroom, give you some tools to explore this on your own as well. So that idea of connected, so not only interdisciplinary, but also connected to real world, connected to their own curiosities, and what they're interested in. And you already saw that in the catapult. They were doing physics, science, technology. Well, they also were doing the engineering because they had to adjust things. And what you didn't maybe see on the screen was actually the coordinates that they had to adjust to be able to make sure it was making it in the hoop or knocking over the wall or whatever they were trying to design. So there's the mathematics. So that experience actually brought together all aspects of STEM. But what was it rooted in? It was rooted in first just this challenge of, can you create a catapult with these materials that will get the ball into the cup from behind the line. And that was their starting challenge. And so that's kind of that idea of connected. Exploratory, that's the piece that's really just looking at how do we let students drive this? How do we let their curiosity really drive forward? And again, you got to see some of that in action. Also, the iteration. In other words, the trial and error. That's part of an exploratory process. Yeah, someone just put in the word tinkering. Great word. Yes, exactly. That's what we're seeing. And so that's part of this exploratory aspect. And again, you saw that where, or the iteration, excuse me, you saw that as they had to take apart and put it back together. And in the digital world, a little easier to take things apart, but still they were trying different iterations. Amplified is really recognizing where does technology truly fit into a STEM room. So often, unfortunately, a lot of times the word STEM ends up meaning technology, and all it means is that we use technology. And I would challenge us all to push ourselves to think a little differently, that technology should be extending our thinking and or our relationships. And that's how it's allowing us to grow, learn, and do in the classroom. Yes, it's also extending what we're able to do, and I realize that, but it's really our focus there is amplifying our thinking, amplifying the positive relationships that we're forming through communications, connections, that sort of thing. Then we look at that relational aspect. That's important. A STEM is a community. You need to be working together, trying to figure this out together. And so you've got that aspect of how do you make sure that there's a feeling of belonging? I worked with a group that was really focused on stars, they were called, but it was looking at scientists, and it was middle school, so grades 6, 7, and 8, girls. And my colleague and I, she helped really design the program. We worked together, and our goal really was when they started the program, we would say, what does a scientist look like? And it would always be a white guy. And so we began to work with them, introduced them to different scientists, got them to see different people, also allowed them to explore and see themselves as scientists. And by the end, what did a scientist look like? I loved the one student who answered it by saying, she looks like me. And that just hit me in the heart, right? Because that's what we're trying to go for. So making sure that our STEM environment is inclusive, has a sense of belonging, but also is responsive to the different ways of thinking. I'll give you another example. We were working with design thinking at the high school level with creating these AI lessons that use design thinking. Well, design thinking a lot of times ends up with this Western concept that kind of somewhat was popularized in Stanford, but other places too. Over in Cambridge too, they have a design place there as well that really popularized this idea that you kind of go through, you empathize, define, ideate, prototype, test, and that's kind of what the steps should go through. But what we did is we said, what are other ways that people design and think about design globally? And so we found some wonderful work around looking at Ubuntu, which is looking at how when you design, you think from both, yes, an individual, but also a community stance. And you're always thinking about the impact on the community. Or a Jugaad, which is looking at how do you sort of think about it from a frugal, in other words, limited resources, how do you design from that way? Two lenses of seeing, so both a data as well as a cultural way as you design. So we introduce these multiple ways of thinking about just design. And then that last is experiential. The fact that we're building the students' competency by having them do things. All right, so those are the 5, not 10, 5 things that we kind of have put into this. And I'm seeing as some are sharing in the chat with us as the hosts, that some of you have actually done the catapult one and have done it with their own students, which is great. What we're going to do is we're going to kind of look at those 5 design pillars, those 5 aspects of design of a classroom, a STEM classroom, and look at some of our starter packs. And what does that look like in those? Now, if you aren't familiar with the starter packs that Classera is able to actually rehost and share out with you, these always have a couple of aspects to them. They have the educator's guide that really takes you through how to run the lesson, how to run the experience. They all are about 2 hours. They have all the teacher's deck, which allows you to kind of work through the questions, the links, the resources right there. And of course, you also have all of your working files, all the files you need to run it. So it's all put together for you to be able to utilize. I'm going to mainly be showing you just the teaching deck as we talk about it and think about some of these resources. So the first one I wanted to kind of look at was this idea of, sorry, we are having some technical issues here pulling up our, there it goes. So I'll just tell you, I'm using Adobe to show because it's an Adobe PDF. And of course, now AI is embedded in everything. So my AI kept saying, do you want to ask questions? Do you want some help? And I was saying, no, I just want to show the PDF. So some of you, I think, can relate to that. But as we look at this, where do we see the, there it goes. Where do we see in the B4 beans? So starter pack. So this starter pack, where do we see the STEM and how can this both ignite curiosity and then lead to creativity while building those STEM components that we always want to see? So this one really takes that on that challenge of, you know, we have impact in the food that we choose to eat. We have global impact. And so it starts off by saying, all right, what is this whole discussion around, you know, do you have cows that you use, or do you use beans, or do you use some other form of protein? And so it starts off by saying, why are we even talking about it? Why do we need proteins? So, ding, 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 here's the science, right? So here we bring in this whole aspect of understanding its function in the human body, looking at the fact that how it works, building up the amino acids, that sort of thing, recognizing what protein do we eat and what protein, how much protein do we need to eat are two good questions to have in there in terms of healthiness. And then looking at, okay, so if this is a need, how do we make sure our world, so there's that global connection. You know, we were thinking of that connectedness. How do we make sure that world is really able to have what they need? So it begins to look at, okay, what can we use for agriculture? Because there's choices about what we choose to plant. What is the impact on some of those different types of food development, production, that's what I'm looking for, types of things. So it really begins to help you look at it. So it gives some information. It ignites that curiosity. It's about something the students have heard about, maybe discussed, talks about themselves and what they need, and then it draws it back to the world. And then it starts to bring in that data. So we're looking at some math aspects of bringing the data, the visualization, and starting to say, okay, here are some different types, talking about what type of visualization matches the right type of data. So you can see now we've got a connection to science and math. Then we bring in the technology. So they actually use Python within a Jupyter notebook to create, based on large data sets that we provide, these visualizations and create those and begin to think through, okay, if this is the issue, using design thinking, always a mindset kind of thing that's important to us, how can we then create something that would help the world in addressing this issue? And so you can kind of see taking them a bit through that design thinking process as we go. But what we've done is that we have now created, we've now had the students start with their own curiosity, move through both science, the use of math with technology to then address this global issue that they're connected to and come up with some different ideas, such as, hey, there are other choices than just either the beef or the bean. And that kind of conversation is forcing a choice that we don't necessarily need to make. And how can we be creative? And so that kind of thing is really helping the students move from some curiosity some things that they're facing into that creativity, but as you see, really connecting them. And if you noticed along the way, think about some of the skills that they were developing as well, such as that whole flexible thinking. So how do you bring data from over here, bringing over, combining it with your own personal needs and the human body needs, the environmental needs, using technology purposefully, looking at how you can choose which visualization you're going to use. And so as you can see, this lesson really brings that whole aspect to bear, allowing them then to have that communication where they are presenting their charts, the evidence for the recommendation that they're making to the rest of the class, or connecting it outwards even more. So that's kind of looking at the this aspect of where we look at connection with some of our STEM starter packs. Here now is a little bit of looking at how that can also look. This, I'm going to go ahead and mute it. This is coming off of another starter pack that we have, and it is music through coding. So what we're doing is we're connecting something that is often thought of as separate, technology and the arts, and really helping the students work through, and as you can see, even using physical devices to also create that music, then to program, make it then play back out through the microbits, and being able to really make this a connected piece that's taking what they're hearing in the arts over into the real world application. And as you can see, the students really get into it because, again, that aspect of the students as creators, we're not just saying you need to now make this one thing. They're choosing the music after having some exposure to different types that they want to try and make, that they are interested in. So so that is the kind of looking at the aspect of the STEM from the connected piece. Now, as we look at this exploratory aspect as well, you can see that this also has some focus skills that are developed along the way, some persistence through productive struggle, some metacognition, equity and relational awareness. We're going to have to see what this one does. So I'm going to bring this one over for us to look at as well. This is better sense. Apparently my Adobe is not going to cooperate with me today. There we go. So this is the better sensing makes good sense, is kind of that idea. Now notice that all of our starter packs are connected to some mindsets, some skill sets, always over to a core curricular area or a STEM curricular, humanities curricular area or a STEM curricular area, purposely so. Now, does that mean that you have to teach this in social studies per se? No, it doesn't. It's just recognizing that, again, STEM is about connecting across. And so this is bringing in some of the content, some of the knowledge, some of the thinking from social studies. Now, what we're going to look at in this one is sort of that exploratory aspect. So the student-driven piece. And looking at the fact that we start off with a very empathetic, having the students take on a different point of view. How would your life be affected if you had a hearing or visual impairment? And they begin to think about different, just everyday life experiences from someone who has a different way of hearing, a different way of seeing, and begin to understand that the world is different, even the way you interact with different people. And so they develop a mobile app to support something that they may be seeing becomes where there could be some support for individuals, because the way we've designed our spaces, our world, our public areas has not been designed with everyone in mind. And so they go through the iterative cycle of first thinking from that empathetic point of view, programming and developing the app, and it gives them some of the tools to do that, of course. And then after they've developed it, they actually think through and publish it. And after they publish it, they're not done though. So often when we do the creation process, a lot of times it's you created it, good job, and we celebrate, which is important, is excellent. However, when we think about a STEM environment, kind of have to think about it like it's never actually done. Now, you can say it's good enough you don't want to keep, as our one friend posted, don't want to keep tinkering, but we do want to keep thinking about how can we make it better? Has it actually met the end goal of what you were trying to create it for? And is it doing the best job it can for that? And so again, that exploration, but also that iteration. So testing the app by going through, making sure it matches your original design and the stakeholders for who you are creating it for. And so this one, again, is our better sensing makes good sense. And creating that app of support is another one where we can see that exploratory aspect of setting up your STEM environment, your STEM classroom, can really develop some of those skills around persistence, the metacognition, stepping outside of what their life experience is and looking at it from someone else's, which is also that equity and relational piece. So now, the question that you've noticed, I keep mentioning these skills. In order for the students to really be successful in a environment where you're really focused on STEM, you can't just drop them in or just grab one of these starter packs and say, all right, students, go. If they haven't been exposed to some of this design of a classroom and of a space before. So start of the year, even if that's how you typically run your classroom and the students are fresh to you, they may need some support to think about those skills. In fact, we have a school that we worked with that I'm going to just have them talk about some of the things they did to help their students. And this is more on the high school side, look in and begin to develop the skills that they need for their future and to be able to function in this type of environment.
The fourth industrial revolution, often called Industry 4.0. And as a result, the skill sets required from students when they leave school and college is different. So we're now looking for students with analytical computing skills, algorithm thinking, AI, data science, and as part of a pilot project with the Tablet Academy and Intel, we're working here at Newtown College to explore some of these areas and have the students do hands-on activities around Industry 4 technologies.
Today we have a fantastic session with Simon Johnson about artificial intelligence as well as robotics. We participate in a series of activities to see how artificial intelligence learns from us as humans.
The first thing we've done in the session was look at some potential future careers. We talked about what we think may be future careers, and then we were given a task. We've been using Python, and we've been given a set of things that we have to draw, and we have to achieve it in the least amount of lines.
So you can hear again, what did they focus on? They recognized the skills that the students would need for their future and started to embed that in, but gave them some smaller tasks, some smaller challenges where they got to practice not only their technical skills, but also some of those skills of deconstruction, so those computational thinking skills, to then be able to move forward into their larger project that they were going to do. So I have another question for our room, which is this one. What skills do students need to be successful in a STEM lesson? So I want you to go ahead and put in some of the skills you think are needed. And again, it's the same type of interaction. If you just refresh the screen that you were on before, it now has a new screen with a new question and you put in a word. If we can also drop that link again in the chat. So I just ask our Classero host if they'll just paste it in again because we have some new participants in. But what you're asking yourself is, what skills do students need to be successful in a STEM lesson? And again, I'm going to show you some other things, and we'll come back and visit some of the thinking that our room has. And we already see some of you. Thank you. starting to come in, creative thinking, curiosity. Thank you, thank you. And so what Skills for Innovation, what Intel did in the development of Skills for Innovation was do what that project that you just heard did, was say, what are the jobs out there? What are the skills that are needed for it? We worked with the World Economics Forum and looked at their reports, such as this one that shows, yes, we do need technology literacy, number 6 there, but some of the core skills that are needed are things such as you've already putting up there: creative thinking, empathy, active listening, systems thinking. And then through that process of analyzing what's needed out there, created this framework that really drives all of Skills for Innovation, not just our STEM focus, but the aspect of we need some of those social emotional pieces. Then the mindsets, the design thinking, the computational thinking, those need to be in place for us to really activate and utilize the skill sets that we can develop. And so it's that same thinking when we're focused more specifically on a STEM environment. Oops, sorry everyone, I moved you on to the next slide and didn't mean to yet, the next poll. So we're back again as I was trying to click through my slides. And so as you can see on this screen here, some of the subcomponents, if you will, of that framework, such as persistence, collaboration, tolerance, empathizing with others, is also connected then with the design thinking mindset. And so you can see it's really been thought through in terms of how we design these starter packs and try to include all of those pieces. So let's go ahead and check in and see what we're doing here. So it's sorting this for us, our wonderful AI, and kind of into some categories that you can see. We've got creativity, critical thinking, problem solving, teamwork, analytical pieces, curiosity, and then more responses are still coming in. So we'll check in on those in just a minute as we continue to think about some of the design aspects as we look at our classroom. So again, we have our 5 design pillars, but what we're realizing is within those, within our classroom, we also have to be very purposefully developing certain skills so that they can function within the connected, exploratory, amplified, relational, and experiential aspect of our STEM classroom. And so here's a bunch of different skills, many different skills that students need to be successful. I took some time to say, all right, if we could bring that down to just a few core ones. And we kind of got it to these 9. And I think you could even, if you wanted to, sort of highlight certain ones that you say, these are even more important than others or more critical than others. And so that's what we have here, though, is these 9 essential skills that we see that are needed for the success in a STEM environment. And by the way, a couple of you have asked about sharing. I'm going to actually provide a web link at the end that has all of these resources. And of course, Classera is amazing. They always share out the resources from our sessions afterwards as well. So if you're registered now or viewing the recording, you're going to have these. Now, I have a challenge for you. Let's come back, though, first and just look at some of the other responses. We're going to have it group those again. And you can really start to see some of the different places that we have. All over the place, lots of different items here falling into place, and still more logical thinking. Technical skills now has come in. Confidence, that's an interesting one. So you can see some of the different ones that are here. So thank you for continuing to share. I'm actually going to move us off of this one because I have another challenge for you. And thank you for being such a wonderful group. These are out of order. This is the one we want next. Which skill is the most important for students and their future? So we took the 9 there for you, and you will see them on your screen sort of displayed in a vertical row. And here's the thing, you only get to choose one. So as we move on, go ahead and vote. Which do you feel like is absolutely essential for our students' future? And we could get into a debate, but I think it'd be interesting to just see what some of us are feeling And some of you are already voting. Thank you for that. We're going to look on as you continue to do that, and we're going to share with you the amplified. So remember, we have our 5 areas. This is the third one, which is amplified. And this is thinking about how technology amplifies or helps to enhance our thinking process, as well as our connection with others. The alchemy of sound is the starter pack here. This is one of our AI PC starter packs. And so with this one, what you really see is that the whole idea is that you're put in the role of, all right, you're going to be a Foley sound effects engineer. And so what that is you gather natural sounds and try to make them work within the animation, within the movie, within the TV show. And so that's the idea behind it. And so we give them a chance to be able to listen, to be able to think about it, to understand what Foley art is, and then we give them the challenge. So we, again, have connected their curiosity with, let's just experience it first by listening. Then we said, did you know how movie sounds are made? And we reveal that, which many of us don't know until we learn through this lesson. And then we start to say, all right, so what are the challenges that those type of engineers or artists, because they're both artist and engineer, what do they fall into? What are the issues that they run into? And so we have them then take on that role. So we give them a video to work with, and then we use AI to actually help them in deconstructing and reconstructing sound effects, soundtracks, through a couple of different applications that can actually sit right on your AI PC. And the AI PC aspect is important because it's doing so much complicated work around it of trying to pull this all apart, that AI aspect of understanding the different nuances, such as pulling apart, because it's not already tracked, pulling it apart into tracks, these different aspects, so that you can really focus in on different pieces. And so we use OpenVino to help with that, which is an AI tool from Intel, and go through that, create them their music, and then they go ahead and plan out their project and they create it. So remember, always again, ignite that curiosity, continue through with a STEM environment to have them actually be creators. And then actually, this is also, again, that whole critique and work with others to create it, because everyone is taking on a different role within this aspect. And you can see here on the screen, as I mentioned with our starter packs, they always provide some of the how-tos as well, if that's needed. But in the end, they get to the point where they get to listen to one another's, share back, and identify that learning process and how it can work. And I'm seeing in the chat that a number of you have said, hey, I've actually used Audacity. So if you do have access to be able to do this type of work, it might be really interesting of how you can combine these multiple technology tools to be able to do this work. So that was sort of the amplified. And as you can see, it's amplifying by making their thinking visual, amplifying their own, enhancing their own thinking by having that inquiry mindset, requiring them to think about roles and ethics and the use of AI, as well as the human creativity. Where's the human element? Where's the AI element? So we have some really good discussions through that work. And kind of that amplification piece with in the STEM environment. Now, we have another sort of story where a different starter pack was used. And this is out of London, the UK. And I'll let them tell their story a little bit here.
We've been using the Intel Skills resources to use as a reference to create the digital twin room, so we have an idea of what to work off and what we're trying to create ourselves.
To make sure that it's as accurate as possible, I use tape measures to get like the most precise measurements. The room is properly represented and it looks very accurate, you know.
We use 3ds Max and we use that to create both mechanical and organic structures within the room. So that can be from like walls to computers and chairs to replicate the different structures you can find in the room.
Since there are going to be people looking around this environment, I want to put as much effort in as possible to bring them as much of as an immersive experience as I could.
All right, and so what they did is they continued to develop this virtual space. So they made a digital twin of first their classroom. And as you heard, there was measurement. Oh, right here, they're actually looking at some different aspects of data capture. So there's your mathematics, the technology, of course, is in there. Then what they do is they actually connected out after they had their digital twin of their classroom and sort of said, what does that look like? That was phase one. They connected out and began to, and here it is. Here's their digital twin. And then they design, how could we redesign the classroom for better flow, for better work? And as you can see, there are the students coming in. Yes, those don't look like students, but that's what they're supposed to be within the environment. And of course, it was a virtual reality experience for them to be able to actually walk through their own classroom. But what they didn't stop there, that real world connection came into place where the technology helped them expand the learning, but also over to relationships. They connected with a community organization that was redesigning a stop and a tram stop, and they went and they did the same thing, did a digital twin of that tram stop to help in the design process and make recommendations of how that could look. And so you kind of see, wow, these students really took it to the next level. But what they were doing, again, was within this STEM environment, we were able to really amplify through the use of that technology. All right, let's check in with y'all. Let's see. So if you had to choose just one of the 9, here were where you, as our wonderful audience, felt was the most important for students and their future. Interestingly, notice even though we're talking technology, we're interacting through technology. We really see that flexible thinking, self-directed learning, persistence, those ranked right up there along with technology within our group here. So thank you for sharing a little bit and thinking with that. We're going to look at that next piece, which is the relational aspect of things. So,
Dr. Jeremy, I cannot hear your voice. Maybe
I'm sorry?
it was your voice was breaking. Maybe I couldn't hear your voice since 10 seconds. Just take 10 seconds or
Okay.
less.
Well, my apologies for that, everyone. There is some thunderstorm going on here, and so maybe that happened. So we were just moving on to the relational aspect of things and looking at that within our starter packs. And some say, hang on, STEM, that's science, that's technology, that's mathematics. Aren't we, the unemotional people kind of thinking? And I think that's an important aspect that we really need to address. And we have this starter pack. This one is more designed for the younger grades. It's called Are You Happy? It uses AI. And again, sort of what this looks at is, oh, there we go. We start off with talking a little bit about online. So actually start the lesson on their interactions and how they act and interact online, having some pieces around some digital citizenship, which is always important to embed in our digital world, our connected world. Then they ask this question again, how do we connect it to their curiosity, to their life experience? How do you feel someone said something unkind to you online? And so we begin to think through that. What does that mean? And how does that work? And so their mission is to allow people to learn about how the impact of what they say or type online could be received by others. So it's actually an empathy training machine that they're creating. And so it's kind of a fun activity task for them. They use Scratch to do it. But what they do is we introduce to them machine learning. and go through, and it has a nice little video, and we talk about what is machine learning and how does it then work. And so using this website, machinelearningforkids.co.uk, really they're able to then set up their own machine learning project. And this can be done without any type of login. So that allows you to not be worried about any kind of data privacy that's going on with some of our younger learners. But then they begin to, after creating their project, begin to put on, they begin to train it. And so they begin to put in there some of the labels around kind words. And so helping that machine understand what counts as kind and then mean words. And you better believe the students really enjoy the time when they get to put in and add the mean words for the training. And so they go through and they do this training exercise of training that machine and using the natural language processing platform, and then using Scratch. So first they trained the machine, then they go in, and in Scratch, they're able to create a character that will react based on the type of words that are being typed into the learning machine. And so you can see it combines a number of different things in here where the students are really learning about the relational aspect of both. Oh, and I forgot to mention, you might have seen it on there. These are done in teams so they can talk together and understand help each other understand from different points of view as well. And so what a wonderful sort of lesson that they can kind of go through and actually create, again, from curiosity to creativity, but developing those skills that they need of empathy, of being relationally aware of others while they're doing it, as well as the technology piece. All right, so let's go ahead, and some of you already started to do this, but as you think through sort of and it shifted some, most important skill, look at that. Thank you for those that continued to vote. It did shift. My apologies. There we go. It's going to reload here. I forgot that I had them out of order. So here you go. Now here's your next, and as you can tell, final question. Rank these from easiest to most difficult to design in your STEM lesson. So as you think about these, and we just talked about the different aspects: connected, exploratory, it alphabetized. So we haven't talked experiential. We're about to amplified, relational, and we're going to talk experiential. Which is the most difficult for you to design? And again, that link is in the chat for you to be able to vote and put your thoughts in, and we'll check in just a minute on what people are thinking in the room. So our last one is that experiential. It's the whole idea that the students are developing these competencies that they need, these skills that they need through actually doing. So it's learning through doing. And we can see that very well in all of our starter packs, quite honestly. But the one I chose to sort of share with you is another one that, there it goes, is at a lower grade level, sort of that, sort of ages 5 to maybe 13. Although all of these can be shifted up or down. That Are You Happy one I've used with high schoolers, grade 9 to grade 10, grade 11 and 12. Even some early university. So we can use these all overs. But what this asks about is, have you ever thought where food comes from? And it really gets into that whole connection. So that experiential part, which also is connecting to the local issues and global issues. And you've already seen how we've done that in some of our other starter packs. This one, though, really looks at that process of thinking about your own farm that you might create and how that might be different depending on where you might live, the types of resources you have, as well as the impact of what you farm would have on the broader community. and making use of that. So they begin to plan their farm as they think about those different aspects, and really going through the design thinking process where they have the opportunity to develop a model and such. And then where they go with this is really looking at Minecraft. And so they go into Minecraft to actually create their farm. And the interesting thing about this one is as they learn the skills of Minecraft, we also have the opportunity to think about what are some of the components that you need to have in your farm and why is it important to have that? So trees, not just important to produce fruit, but also air quality and such, thinking about the tools that are needed within there, thinking about the house in different aspects. Why are rivers important to farming? So we've taken it, don't forget your animals. We've really taken it from this beginning question of where does your food come from to how can you be designing a thoughtful and responsible farm in the location in which you live, or assign the students other places. And then thinking about the different aspects. So again, what they've gone through is the science around all the farming aspects, that whole biological aspect. We've looked at the technological piece using Minecraft, but also the technology that you need to run your farm, the engineering aspect of thinking about the design and layout, as well as some of the buildings that you're creating. And of course, the mathematics. If you haven't used Minecraft, you are constantly needing to do some quick math, whether it's in how to design in terms of the number of blocks, or whether the angles that you're working with, all of those aspects that you have to be thinking about when you are designing in the Minecraft world. And so again, another one that brings in all those pieces, starting with the curiosity and moving on. And so we've really looked at these 5 aspects of pieces of this STEM learning design framework: connected, exploratory, amplified, relational, experiential. And here's where our room is kind of feeling, which is ranking them from easiest to most difficult to design for. And you can kind of see easiest is that connected piece. Most difficult is often that amplified, that technology. How do we really make that all work piece that comes into play? Well, what we've done is we've actually created for you a little resource as part of doing this session. And again, I'm going to drop that in the chat and ask that our wonderful host go ahead and share it. But I'm going to show you what it will take you to. So it takes you to, it's got quite a few words on the page, but it's designed to allow you to kind of click through it and be able to utilize it multiple ways. So the full STEM learning design framework is here at the top. But then down below, in those 5 areas, those 5 pillars that we were talking about, it then allows you to choose your different pieces that you want to focus on and gives you some ideas of ways that you don't have to necessarily start at the full huge projects. You can bring it down to what are some ways you can do this within your classroom to build those skills that the students need to be successful when using, say, the starter pack and some of these other resources. And so again, this resource is meant for you to be able to look into some of those areas that your students may need some help, choose your grade level, and get some just starter ideas of where you could embed this in your everyday, thinking about it from a different progression, where they're at that grade level that they may be focusing on and what you might be wanting to do. So that's sort of the idea here around this resource that we've developed for you. And you can also filter by some of our other areas as well. We do have it so you can print it out if you want to as well. So that's a resource we developed specifically for you in this session today, looking at our STEM learning, our design framework. Just want to call out a few things. So with Skills for Innovation and our partnership with Classera, there's also professional development that is available. And we do have, as you can see, a whole suite of professional development pieces. But if you look at our levels 2, 3, and 4, so you can kind of see all of these. But if you look at these levels 2, 3, and 4 specifically, you can see how these sessions, most of these courses, really are talking about how do we help to develop, such as critical reasoning, analytical thinking through data, bridging that creativity gap, going back and looking at how do you strengthen real world relevance in your classroom. All of these were components that we identified were critical for our STEM classroom and those 5 pillars. And so we have these courses for you to be able to utilize through Classera. I do want to just call out, you saw those. We do have 2 additional ones that are not part of our standard levels. One that I think is so helpful for our conversation today, how to develop higher order thinking with our SFI mindset and skill sets. So you can see in there, you've got your computational thinking, how to integrate that, and how to integrate design thinking into the classroom. So those are some courses there for you to be able to utilize as well. And then the other one is, if you weren't aware, we also have our artificial intelligence one as well, that, as you saw, 2 of our starter packs that I shared, we're using that artificial intelligence, and we're just seeing it used more and more as we think about those skills for innovation that our students are going to need. And so I want to just thank you very much for spending an hour with me today, having some time together. I've definitely enjoyed being able to meet with you all and to interact. I'm going to turn it back to our amazing hosts at Classera to just share, how do you get to those resources?
Thank you, Dr. Jimmy. Thank you so much for this amazing session. It was truly excellent as usual. And thank you to everyone who joined us today. I hope today's session provided you with some insightful and impactful insights about STEM education and technologies in education in general. And remember that the important part of the whole process is you and your role in transforming education and helping build a future-ready generations. Let me also remind you that all the Intel SFI content is already available, as Jermaine said a while ago. It's available just 1 click away. And let me share with you how and where we can access that content through your Classera account and through the LMS account. So allow me to share the screen. Yeah. So once you open your Classera account in the landing page, you will find the professional development here and also Intel SFI or skills for innovation, where you can search the professional development and also the starter pack. And you can also filter the results. You can see, as Dr. Jermaine said, we have the 4 levels. You can see the 4 levels here in Arabic and English, and you also can filter them here. So if I'm selecting or searching for the professional development and also the level 2, for example, I can search for the specific course. I can also select the language from here. And once I finish, you can start the whole process and select the course you need. This is one way actually to access the SFI content through your LMS account. Moreover, this content will be available on Classera e-learning platform next month, inshallah, under learning passes and also categories, making it even easier to you to access. And by the way, you can also obtain the attendance certificate through the same platform, Classera e-learning platform. And I'm gonna send the link one more time in the chat. So simply you can log in using the same Classera credentials through the link that was shared in the chat. I'm gonna share it one more time. Then you can enroll to the course, submit your feedback, and once completed, your attendance certificate will be instantly available. Okay, that's about accessing the content. Before we wrap up, I'd like to highlight that our upcoming webinar with Intel and Dr. Jermaine will be on the 2nd of Feb. See you soon, inshallah. It will be about project-based learning with Intel. SFI, of course. Also, don't forget that our previous webinars, also along with more than 100 additional courses, are available on the Classera Innovation in Learning, e-learning platform. You can watch the recording anytime and continue your professional growth. Let me share the link here one more time, and also mention that the session also is recorded, and you can access the recording either from the same link you accessed from or on the e-learning platform. The PowerPoint will be there as well, will be attached to the course in the e-learning platform. You can access the content through this link. Yes, exactly. The certificate will be available on the e-learning platform through this link. You can access once you log in, you will see the, yeah, let me share it one more time, sorry. Okay. Yes, you can see the link in the chat now, where you can enroll to the course using your Classera LMS account. And also, once you log in, you will see the pop-up screen that tells you about the course. Just click on it and do the survey. It will be available after maybe 30 minutes from now. Once you do the survey, you will get your certificate, and also in there you will find the attached PowerPoint and the material and everything, and also the recording, of course. The LMS, we mean Learning Management System, Classera Learning Management System, and also the SFI, that is Intel Skills for Innovation training courses and professional development tracks that we were presenting. So I hope you have a great time today with us, and you have learned something new and got some impactful insights. Thank you once again for being part of this event and part of our learning community. We look forward to seeing you in the next webinar, inshallah. Thank you so much. Thank you, Dr. Jermaine, and see you soon, inshallah.
Yes, thank you, and thank you, everyone. We'll see you all online soon. Cheers.
Bye-bye. I leave the webinar for more 30 seconds just to get the link if you would like to have it one more time, and then we will close the webinar. Thank you so much. See you soon. Assalamu alaikum wa rahmatullahi wa barakatuh.